Alright, this is lesson 1-4, building functions from functions. And this is, if you remember from Algebra 2, the f of g of x and the g of f of x. What this basically says, the composition of the function f with the function g is h of x equals f of g of x. The domain of h is a set of all x values such that x is in the domain of g and g is in the domain of f. Basically, in a nutshell, what that says is the domain of your composite function, of your composition, cannot be larger than the domain, and let's say the composition f of g of x, of either f or g. Okay. And that's what I said right there. Whoops. I'm skipping. Alright, here we are at the problems. It said, given f of x equals x squared and g of x equals the square root of x plus 1, find each function below. F plus g is just f of x plus g of x. Now, if you look at the domain of f and the domain of g, the domain of f is all real numbers. The domain of g is x is greater than or equal to negative 1. So if I want to find the domain of f plus g, again, it's still x is greater than or equal to negative 1 because you cannot take the square root of a negative number. There's no restriction on the x squared. F minus g would be x squared minus the square root of x plus 1, again, where the domain is x greater than or equal to negative 1. F times g would be x squared times the square root of x plus 1, still greater than or equal to negative 1. F divided by g is x squared over the square root of x plus 1. This one, though, the square root is in the bottom, so x cannot be equal to negative 1 either, so it's just greater than. Now, g and g is where this whole the domain can't be bigger thing comes in. If I do g of x times g of x, that's the square root of x plus 1 squared, which is x plus 1. But the domain still has to be greater than or equal to negative 1. Because if I said it was greater than or equal to negative 1 initially, if I said that g of x has to be greater than or equal to negative 1, then I can't use negative 3 because x has to be greater than or equal to negative 1. And even though my answer, my GG, has no restriction on it, because this domain's all real numbers, you still have to say that x is greater than or equal to negative 1 because you have to pick the smaller of your domains. Okay, next. F of g is f of g of x. That means you take the g and you plug it into the x right there. So that is e to the square root of x. G of f of x just means you take the f and you plug it into the g, the square root of e to the x. Blank page. F of g of x again. And we're going to look, and this one actually asks us to find the domain, so let's go up here. The domain of x squared minus 1 is all real numbers. The domain of the square root of x is greater than or equal to 0. F of g means that I would have the square root of x squared minus 1. Now that's just x minus 1. That in itself has no restriction. However, because I had a restriction initially, my domain is still x is greater than or equal to 0. G of f, I plug my f into my g, and it'd be the square root of x squared minus 1. Now this is the tricky one, because what's underneath the square root has to be greater than or equal to 0, and that's the one where we would have to do a sign graph. So we'd have 1 and negative 1. negative 1, 1, x plus 1, x minus 1, negative, positive, positive, negative, negative, positive, so it's positive, negative, positive. Okay, and we want to know where it's greater than 0, so it would be from negative infinity to negative 1, and then from 1 to infinity. Now here's the thing. It also has to be greater than or equal to 0. So if we look at our number line, 0, initially I said this is my domain of my initial function. And now I'm also saying that it has to be here and here. Well, these two are not included in this. Well, this one's not included in the pink. So what's the smallest of these three domains? It's this one. This is the only one that includes the x is greater than or equal to 0. You can't say that x is greater than or equal to 0 because it also has to be bigger than 1. It has to satisfy both conditions. So my domain would be x is greater than or equal to 1. For each function h, find the functions f and g so that f of g of x equals h, that, yeah, just that. G of x is my inside function, okay, so can you tell that the x plus 1 is the inside function? So g of x is x plus 1, whereas f of x is what's left is something squared minus 3 times something plus 4, because that's what I plugged it into. So f of x would be that something is now an x minus 3x plus 4. Same thing here. The inside function, whoops, I should probably do that pink to match my g. Sorry. My inside function is x cubed plus 1, so g of x is x cubed plus 1, whereas f of x is my outside function, or my square root of x. Example 5. Function modeling, blah, 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 you can read. Suppose the balloon is inflated at a constant rate. This is the part that's really important. 44 cubic millimeters per second. It says find the volume after t seconds. Well, if my t was 1 second, I would have 44 millimeters. It would be 44 cubic millimeters, because that's a measure of volume. After 2 seconds, it would be 88. After 3 seconds, it would be whatever 44 times 3 is. So my volume equals 44 per second times t. It says when the volume is v, what is the radius r? All that is asking you to do is solve for r. Now it says it's a spherical balloon, so that's 4/3 pi r cubed. So I'm going to solve for r. So I would divide by 4/3 pi. Now dividing by 4/3 is the same as multiplying by 3/4. So 3/4 pi, whoops, pi's on the bottom. 3/4 v over pi equals r cubed. I can take the cube root. So r equals the cube root of, and the 3 is on the top with the v, and the 4 is on the bottom with the pi. And that's solved for r. It says write an equation that gives the r as a function of t. In other words, I want r of v of t. So I want to put that one right there. And that will give me r equals something as a function of t. And then I stick my 5 in, the cube root of 3 times 44 times 5 over 4 pi. And that's just, oops, I didn't mean to do that. Stupid thing. I want it to pull over here and stay. No! You're probably laughing at me right now. Okay, here we go. The cube root control, and then make that a little 3 of fraction 3 times 44, whoops, what just happened? 3 times 44 times 5 over 4 pi. Control enter because I want a decimal. 3.745. So that is 3.745 millimeters. Verifying pairs in a relation. It says determine which of the ordered pairs are in the relation. Is the relation a function? Well, we just check them to see if they work. 2 squared times -5 plus 2 squared equals 5. That is true. 1 squared times 3 plus 3 squared equals 5. That is not. I've already done this one time today, so that's why I'm going so fast with it. You can mark it out on your calculator if you want to. Equals 5. That is true. So because both of these worked, it is not a function because the x's repeat. That's where we stopped. We actually went ahead and did this one, but in retrospect, we don't need to do that yet. We're going to do that later, so don't worry about that one. The end.